So find where we left with our unit circle. You have it filled out, but beside it, you should have some space here. I want you to draw a 30-60 right triangle and label it. And draw a 45-45 right triangle and label it. And what we're going to do is learn how to evaluate without a calculator. Remember yesterday I told you to make sure, and we wrote it on this screen, you needed to know pi over 6, pi over 4, pi over 3. Those have to be knee-jerk, quick, I know what those are. So, if I ask you to evaluate without a calculator the sine of pi over 4. So Henry, how many degrees is pi over 4?
45. Good
job. It's 45 degrees. So I come over to the 45-45 right triangle, and I know SOHCAHTOA. Sine is opposite from 45 over hypotenuse. That's 1 over radical 2. And that rationalizes to radical 2 over 2. Cosine, pi over 3. McKenna, how many degrees is pi over 3? 60. So I'm going to come to my 30-60 triangle, and I'm at 60 degrees. SOHCAHTOA. Cosine is adjacent over hypotenuse. So it's 1/2. Tangent, pi over 3. So we already did pi over 3 is 60. So I'm sitting at the 60-degree angle, TOA, SOHCAHTOA. Opposite over adjacent, that's just radical 3. Don't let it bother you if we have a reciprocal. Secant, pi over 6. So Megan, how many degrees is pi over 6? 30. Okay, so first of all, I'm going to be in my 30-60 right triangle, and I'm sitting at 30 degrees. Now secant. Elena, do you remember what trig function is the reciprocal of secant?
Cosine.
It's cosine. Okay, so now, you guys, this is what gets complicated about this. Is you're going, all right, I have to figure out that pi over 6 is 30 degrees. Secant is the reciprocal of cosine. SOHCAHTOA. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So I'm at 30 degrees, and I'm doing hypotenuse, which is 2 over radical 3. I can rationalize that to 2 radical 3 over 3. So these are not quick. You have to think about it, get the right ratio from the right angle, okay? All right, next. Definitions. A sector is a region of a circle that is bounded by 2 radii and an arc of the circle. So let me get my handy dandy circle tool. Ooh, isn't that neat?
That's not fair.
Yeah, sorry, you don't have that.
Wow.
Okay, so here we go.
Are you recording?
I am recording. Okay, so
That's gonna be on there.
I know this will be on there. All right, great. I'm embarrassed now. Okay, so theta is a central angle, and if you remember from geometry, a central angle is formed where the vertex is at the center of the circle, and so a sector is almost like a piece of pie, you know. And so what we can do is we can find the arc length. This is S. And S is equal to r theta. But you need to remember that theta has to be in radians. So if they give you the degree measure, you have to convert theta into radians for this formula to work. The area is 1/2 r squared theta. You guys, these two formulas are on the ACT. So arc length, r theta, and area of a sector, 1/2 r squared theta. Those are two you'd like to know. But in both cases, theta has to be in radians. Go ahead and open your textbooks to page 862. And there is a picture of a softball field. And I'll do my best to draw something like this.
Don't have that one, do you?
No, I don't. Well, we'll see.
Oh,
Nope.
You have that weird looking funky shape at the end. There might be more.
no.
Yes.
I do! Good thing you asked. Okay.
That's not fairy.
Ooh.
This is definitely not fair.
That is
It's
so
in the
cool. I'm so
recording.
glad you said something. That was fun. That is so fun. I didn't realize I had that. Okay. Yay. Now mine's backwards, isn't it? But that's okay. Now this angle that's formed is a right angle. So it says a soft ball field forms a sector with these dimensions. So it's 180 feet. Find the length of the outfield fence. So this is a sector of a circle, and this is the fence. So that's arc length. So S equals r theta. The radius is 180, but theta is 90 degrees. And what I just told you is that theta has to be in radians. So we're going to multiply by pi over 180. 90 goes into 90 once, 90 goes into 180 twice, so the angle is pi over 2. If I reduce that, you're not going to go to Lowe's and say, hey, we just built a softball field at our school and we need 90 pi feet of fence. So you're going to want to take out your calculators and multiply 90 times pi, round to the nearest whole number, and I got 283 feet. Yeah.
Could we have also looked at the unit circle and saw that 90 degrees is pi 2?
Yes,
Pi over 2,
absolutely.
not pi 2.
Pi over 2, yes. All right, then the area of this sector is 1/2 r squared theta. So it's 1/2 times 180 being squared. And you guys, don't do the work again. We already converted theta, so you're going to use it twice. Take a moment and punch this in your calculator. Let's see if we can get the right answer. Round to the nearest whole foot. I got 25,447, and this is square feet because we're talking area. All right, now, do you have a little bit of space either at the tippy top of your page? We're going to do a little bit more work here. One other thing.
Can we put our books away?
Yes. We want to learn how to evaluate with a calculator, and there's two main issues I want us to look at. So you do need your calculators out still. Sine pi over 7. Is pi over 7 degrees or radians? And how do you know? It's radians. How do you know?
Because of the pi.
Not because of the pi.
There's no degree sign.
There's no degree symbol. Okay? So don't think just because you can have pi degrees. It's not common, but so here's what we're going to do, and I want you to write this down. Check your mode. You hear me say that often. Now you guys are going to hear it the rest of the school year. So we're going to press mode and change it back to radians. So now sometimes you're going to be in degree mode and sometimes you're going to be in radians, and you should check often, are you in the right mode? So then we're going to take the sine pi divided by 7 and press enter. Let's round 3 decimal places. So that's 0.5 .434. Again, .434. All right, now, something I need to tell you about, and I'm going to tell you a common mistake that I see. There is no button on your calculator for secant, cosecant, or cotangent. And here's the thing, and I will have students who say this is the sine of 5 over pi, and that's telling me we don't understand what we have. Okay, cosecant is the reciprocal of the sine function, but we don't flip the angle. We're flipping opposite over hypotenuse. You're flipping the fraction answer, not an angle. So that's somebody who's being careless and not thinking through. What I do know is this is the reciprocal of the sine of the angle. Okay? So you never ever flip an angle. Okay, don't do that. Don't make it sine 5 over pi. I don't know. I know what a student's doing is they're remembering, oh, it's a reciprocal, so I'm just going to flip it. Okay, then that tells me we didn't understand what we were flipping. Okay? So let's go to our calculators, and we're going to do 1 divided by sine pi divided by 5. Round 3 decimals, and that's...
Oh, it's 1. You
Oh, okay. It's like, wait, that's not the right answer. You press second enter, and I can just delete one of those ones. There we go. There we go. 1.701. Okay. Let's try one more. Let's do cotangent, pi over 8. So first of all, and you should do this on your paper, what should we write down? What are we going to end up typing in the calculator? 1 over tangent pi over 8. And you should get in the habit of writing that, because if you do this all on your calculator and you write nothing down on your paper and you did something wrong, I can't even give you any partial credit. But if you wrote this down and then it was an entry wrong, then, you know, I can work with that. So I have 1 divided by tangent, pi over 8. And are you getting 2.414?